that was part 2. Now this is a new one. All right, so today we're going to talk about the sum to product and product to sum formulas. Today we are wrapping up all the formulas on our trig chart.
Yay.
Hooray! All right, now, if you are comfortable with it, I am comfortable with letting you know there are some math nerds out there that have gone to a lot of trouble and have proven these things. And these bottom 8 formulas are legitimate. Can you take my word for that?
Yes.
Previously, we've been deriving them and showing how they come from, but if you're okay with it, I'm going to leave them right there. Is that okay?
Yes.
By the way, if you're curious where they come from just variations on the sum and difference formulas, okay? And if you look at them and compare them, then you'll kind of figure it out. Let's go ahead and examine them, though, and make some observations. Let's look at the sum to product formulas, all right? And let's look at the left-hand side of all of those sum to product formulas, all right? Now, what do you notice about the left-hand side, folks?
They're the sums. Or sums and differences.
Sums and differences. But isn't a difference really just adding a negative number?
Mm-hmm.
So you really, if you want to be sort of general, you could call everything that's addition and subtraction, you call it all sums, right?
Yeah.
What do you notice about the right-hand side?
It's all multiplication.
It's multiplication. It's 2 times the sine of blah times the cosine of blah. Yeah. Hence the name sum to product. Now, and there's 4 of them there. Sine, 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 cosine, 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 cosine with a minus or a plus in the middle. Now let's look at the product to sum formulas, class. What do you notice about the left-hand side?
All product.
Ding, ding, ding. And on the right-hand side?
All sums.
There we go. So I think we've got it. And these formulas are really just opposites, not opposite sides, but I mean like
they're like
similar,
the flip of each other.
They're related. They're like what?
They're like the flip of each other.
Kind of, yeah, kind of like flip. They're kind of like I'd say they're sort of like a fraternal twin. You know what I mean? It's kind of the same thing, but they kind of look different, Isn't that what fraternal twins are?
Yeah.
The ones that they're not identical?
Yeah, they weren't in the same bag.
The biology. There you go. All right, here we go. Let's look maintain.
That is what it is.
See, I told you we were going hyper speed. Yeah. All right, here we go.
Just got handled.
Find the exact value of each expression. So this one says cosine 3 pi over 8, sine pi over 8. Does that look like a product or a sum?
Product.
This looks like a product. All right. On the right-hand side, let's figure out which product we want to use.
The cosine U cosine V.
Yeah, the cosine sine.
The what?
So the formula says cosine U sine V equals 1/2. I'm writing it up here for reference. Sine U plus V minus sine U minus V. All right, and excuse you. U is 3 pi over 8, and V is going to be pi over 8. All right. No need, Chloe, to transition this to degrees. Okay. Let's just make sure. Let's handle the radians here. I know you like to, but we're gonna have to bite the bullet and radian at some point. It looks like we're going to need to know what U plus V is and U minus V is. Do y'all agree with that?
Yeah.
Let's see if we can figure that out just before we fill everything in. So U plus V would be 3 pi over 8 plus pi over 8.
That's 4 pi over
4 pi over 8. Yeah, you can handle that. Can you reduce that?
Yeah,
Yes.
that's 1/2.
One
1
half.
pi over 2.
Pi over 2. Okay,
Oh
great.
my goodness.
What about U minus V? That's going to be 3 pi over 8 minus pi over 8.
So 2 pi over 8.
Which is
and then
pi over
reduce.
4.
I like it. So that means I can rewrite that phrase right there
Look at us, y'all.
as equal to 1/2 bracket sine
Pi over 2.
U plus V, so pi over 2 minus sine
Pi over 4.
ding 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 bracket?
So much better.
Alright. Let's look at a formula chart, or, yeah. Sine of pi over 2, anybody?
So we go to pi over 2.
Look at the 1 because it's the y's, right, Andrew?
Yes.
And sine of pi over 4?
It's root 2 over 2.
You're gonna love this. Alright. So I have 1 minus root 2 over 2. Looks like we're gonna have to combine these terms.
You gotta turn the 1 to 2 over 2.
Yes, turn that 1 to 2 over 2. So that's gonna be 2 minus root 2 all over 2. So multiplied by 1/2 means you multiply the numerators, which is just 1 times this, so it's the same thing, 2 minus root 2. And multiply the denominators, which gives us 4. And we're done.
Awesome.
With part A.
Oh, I circled it.
Well, I mean, that's that one right there.
Oh, okay.
Now, let us look at part B, I guess. Say, cosine 7 pi over 12 minus cosine pi over 12.
Negative 2 sine.
Alright, so we're gonna go for it, right?
Yes.
So you take this as a product, or no, this is a
Sum to product.
sum to product, and it's which number?
Cosine, cosine, the fourth one.
Fourth one, yep. So
Yeah.
equals negative 2 times the sine u plus v over 2. Let's do a little side problem over here so we don't have to write everything. So this is our u, this is our v. So 7 pi over 12 plus pi over 12 divided by 2.
So you can they already have the same denominator.
They do. 7 pi over 12 plus pi over 12 is
it 2 pi over 3?
8 pi over 12 and then
8 pi over 12 all divided by 2. Now you want to reduce that, right? So you're dividing by 4, so that's 2 pi over 3 still divided by 2. Am I going too fast?
Oh, yeah.
And then once again, fraction of fractions, write the numerator times the reciprocal of the denominator. So 2 pi over 3 times 1/2, the 2's would cancel, and I end up with pi over 3. Oh my gosh, all that stuff. Pi over 3. Still looking at the formula here, times the sine, and this one is u minus v over 2. Oh, it is all over here. So here we go. So 7 pi over 12 minus pi over 12. All over 2. Call it out to me, class.
Is it pi over 2 divided by 2? Wouldn't it be?
Well, yes, but you're skipping steps, and I try not to. Yes. 6 pi over 12 over 2, which is pi over 2 over 2. So that's pi over 2 times 1/2, which is pi over 4. There's other ways, but that's a great way of doing it. All right. Equals negative 2. What is the sine of pi over 3, anybody?
3 over 2.
Sine of pi over 4?
Root 2 over 2.
So, treating that negative 2 as like a fraction, negative 2 over 1, I have negative 2 times the square root of 3 times the square root of 2. Square roots you can multiply, so that's going to be 2 times the square root of 6, all over 1 times 2 times 2, which is 4. Negative 2 over 4 simplifies with negative 1/2, so I have negative the square root of 6 divided by 4. You cannot simplify
Over
stuff
2, right?
over 2, right. You cannot reduce something that's inside a square root. So we check the back, is that the right answer?
You cannot reduce anything inside of a square root, even if it's like
Well,
root 6 over root 3. Could you?
because square root of 6 is like,
But you
2
wouldn't
point
want that anyways, right? Because you want to rationalize the fraction.
well, the thing is, something that the square, I mean, if it's the same thing up here as this down here, and square root of 6 is the square root of 3 times the square root of 2, the square root of 3 is different from 3. So,
So you would just leave it as the square root of 6 over the square root of 3?
yeah, I mean, yes, you would. Can I show you, yeah, because it's like, yeah, root 6 over 3, is that what you're asking?
No, the square root of 3.
Oh, absolutely, you would want to do that. Yeah, you could change that, because that's root 3 times root 2 all over root 3. If you've got that, then yeah, you want to reduce it to just root 2.
Okay, yeah, that's fine.
You and your what ifs, Gia, one of these days. A friend of mine, he loved history. By the way, those other two were pretty much the same. He loved history. He read this one book called What If? And I think it was a series of like essays or something like that by a bunch of historians, and it was like, what if, like, I think it was mostly dealing with presidents, like if this assassination attempt was successful, or what if this person had won against somebody else, like what if Nixon had beat Kennedy, stuff like that. It was kind of a little, it was actually a pretty big book. Anyway, are you okay? I feel like 2 and 3 y'all can do, right? Just applying those formulas, okay? Oh my gosh, hope we got some paper.
Oh no.
I would hope that was a sarcastic.
I know, I hope that was sarcastic too.
Find out. Alright, here we go. Make sure my board's all erased here.
It's not.
Okay.
Oh,
So,
he erased the whole board.
cosine 7b times cosine 4b. Now, does that look like a...
It's a product to some.
It's a product sum, I agree. So it's cosine, cosine. So which number is that?
The
Your
second one.
second one.
Mhm.
So call it out to me. So 1/2. Okay, 1/2. I got you. All right.
Bracket.
Bracket.
Cosine.
Parenthesis. U minus V.
Can you do that in your head? The u minus v.
Yes.
7b minus 4b.
3b.
3b. Close parentheses. Keep going.
Plus cosine
10.
U plus V, so 11.
11.
Oh.
11b.
What did you say?
I said 10b.
That's okay.
All right.
This went off. You did it really quick.
Oh, by the way, you cannot combine those cosines because they're cosines of different things, so those are different terms. So let's go ahead and distribute this. So we have 1/2 cosine 3b plus 1/2 cosine 11b. My drama. That's it.
That's it? That's the answer?
Can you combine those?
Live.
I literally wrote lower on my paper.
I literally wrote it on a whole different piece of paper.
All right.
I did.
Well, looks like I got you this time. Is that the answer?
Yeah.
Yes. I like that.
Oh.
Yeah, 1/2 is okay. And the other ones are just utilizing the same formulas. So I am confident that you can do this. If you can read a formula, you can apply it.
Oh,
Okay.
I like this lesson.
Let's do one more.
Why
No,
tomorrow
we
not
have
work?
homework.
Yeah.
But we only have like what?
Which question
5
got you?
minutes left.
Why is
Exactly.
tomorrow not
I can
work?
finish a problem in 5 minutes.
For real, we just
We had like
finished
2 work days last week, I think.
No.
That's a lot.
We did have 2 work days last week. I have one work day scheduled throughout the rest of this semester, so that we
Oh.
can. I mean, one work day a week,
Oh.
so that we can complete what I want us to complete.
These homeworks though.
I know, they're so hard.
Are they really?
The
I mean,
one from
Not
yesterday
this
was rough.
one, not this one.
The one
I
from
mean,
yesterday is all
You
one
gotta-
from
First two are rough.
I mean,
Yeah.
if you wait for 3 days to do it, it will be rough. But if you do it the day of, you know, I mean, I'm not making you do it the day of, but if you can get yourself to be that disciplined, and I know that you don't always have time. You've got different things, basketball, you know, UIL computer science, you know,
UIL computer science.
art, I don't know.
Which one do we do this week?
What's due this week?
Which homeworks?
28, 29, and 30.
Alright.
We just wrapped up 30.
So is tomorrow work day?
Tomorrow, no, it's not a work day. I
Oh,
can kill
well,
it.
you heard that, whoever's watching this.